What's going on, guys? My name is Quinn Clark with Throtl. We got our 4G63 back from the machine shop. Now it's time to start assembling this motor. If you guys haven't seen the teardown of this engine, I'll put a card up in the corner for you. Be sure to check that out to see kind of where we're at with the build. Before we get started assembling, let's go over some of the parts that we're going to be using for the long block itself. So to start, we have an ACL oil pump. Now we are going to be changing some of the setup on the engine due to popular requests, and one of those is a balance shaft delete. So I already have the pump completely assembled with the balance shaft delete kit that we got with our timing belt kit. These are the balance shaft bearings. So the kit that we bought came with replacement bearings instead of using the old bearings that were in the block. We have an action clutch going on. We have a full set of 3G 4G63 lifters. Apparently they're superior to the 2G lifters, so we're going to be running those. Full ARP hardware, main studs, head studs, and then the rods are ARP 2000 that came with our connecting rods. HKS MLS head gasket, and then the full top end is all Brian Crower. So machine shop did all of the top end stuff already. We have Brian Crower valve guides, Felpro, valve stem seals, Brian Crower springs and retainers, cam gears, and a set of stage 2 camshafts, along with a beautiful blue Greddy timing belt. For the short block, we have a set of Brian Crower H-beam connecting rods and a beautiful set of JE forged pistons. These are stock size, stock compression. They are just pretty much a factory replacement piston that is forged. Beautiful work done by JE on making those. Aside from that, we have a set of race ACL rod bearings, throtlVIP main bearings, and then a beautiful bunch of factory parts for the timing belt system, tensioners, pulleys, all the good stuff. And of course, all of the machine work is done on the block and it looks absolutely beautiful. So we have not spec'd any of the bearings for the engine. We have not spec'd any of the piston ring gaps. We have to do that. All the journals seem to be in really good shape, so hopefully this should go together fairly quickly. We are going to be using standard size bearings all the way around, and it's going to be epic.
Alright, so before we continue with this video, I want to talk to you guys about the Code Speaker 2.0. We have been using this speaker for about a little over a year now, and this thing is insane. It is loud. One of the best things about it is that you can break it in half. Now you have a left and right stereo. I just connect my Bluetooth and I listen to my audiobooks, my gaming, or Bad Bunny. Once combined together, they sound extremely loud. On a single charge, I get up to 7 hours of playtime. It is water resistant and it has a built-in microphone that has about a 30 feet range. And not only that, but it makes an easy gift to give to somebody. I pretty much take my Code Speaker 2.0 anywhere. I use it in my garage, I use it here in the shop, and sometimes in some of my vehicles I don't have a stereo in it. And for the 1st of July, they're gonna have an insane sale at 68% off. So go to the link description below so you can get your Code Speaker 2.0 today.
To start off this engine build, we need to install our countershaft delete bearings 180 out. I pounded the old ones out before I sent the block in for machine work. So I've got a big socket flipped backwards and we're just working the new bearing in. Now we can start gapping the replacement rings. We got to replace the rings that Brian Spillner fried. So these are the new ones that came with the JE pistons. So I've got them laid out on the table. When you gap rings, you want to gap the ring to the bore it's going into. So there I'm checking the gap on the rings just straight out of the box, and they're a little bit too tight for what we want. So there's my little ring grinder. We're going to open those guys up and get them to where we want to be. So we are going to be running more boost on a bigger turbo out of this engine, and we may or may not be running nitrous, so I'm gapping the rings a little bit looser. So I'm gapping the rings looser than they would be on a factory engine. We're going for the spec that JE provided with the ring gaps for the level of boost and power that we're going to be running out of this engine. Factory ring gaps don't work with forged pistons because they do have different thermal expansion rates, so forged piston ring gaps are usually a bit wider anyways. This being a performance turbo build, we do want to make sure we have enough clearance so that thing doesn't get hot. Now we got our piston ring gaps established and are all good. We can start assembling the piston and connecting rods. The first thing I'm going to do is inspect all of the parts, make sure the pistons are in good shape, make sure the rods are in good shape, and that the wrist pin slides through the piston and the rod properly. So we're going to lube the connecting rod and then we're going to lube the wrist pin itself. So there's the lube on the wrist pin, and now we can slide those guys together and we can start tackling the circlip on top. And these guys are a little bit of a trick to work out, but they're not that bad. And there's the first piston and rod, and so we're just going to slam through the rest of them, get these things dialed in. Now we're going to be getting into speccing our main bearings. So I had the machine shop actually spec our bearings for us, but we were going to double check them with plastic gauge and then check the thrust to make sure everything is good with the crank before we go for the final assembly. So I'm just popping the mains in. So there's our ARP stud kit, and we're dropping the main bearings in, dropping our thrust washers in, making sure everything's nice and dry for a good reading on the plastic gauge. So just laying out the plastic gauge on the mains, then we can drop the cradle on, get everything all snug. Got some nice ARP fastener assembly lube on there, getting it worked down. And then we can go for our torque. So there's the first round, second round, and the third round of torque. And our main bearing clearances were actually right on money. So they were about right in the middle of the spec. So with bearing clearances, they'll give you a spec range. From a minimum to a maximum, ours were just about on perfect. So we pulled it off, cleaned the plastic gauge off, and now we're going to be checking for crank thrust. So crank thrust is a forward and backward movement of the crankshaft. When it's causing problems, it's called crank walk. Our thrust was actually on the tighter side of factory, but it was still factory spec. These engines, you can have about 2 to about 7 thousandths thrust. We had just over 3.5 thou. So right on the money. This thing should be in excellent shape. And another thing for crank thrust is when you check it, you want to spin the crankshaft 180 degrees and then check it again to see if you have any differences. If the thrust rating is different 180 out on the crankshaft, it could be caused from a bent crank or your main journal is out of alignment, but this engine was on pretty much perfect condition, which is really nice. So now we can actually do the final assembly on the crankshaft, which is going to be lubing all of our bearings, lubricating our thrust washer, and torquing them down for the final time. So one thing I like to do is put the rear main seal on after the crank goes on immediately, because putting the main seal on after the engine is completely assembled is kind of not the way I like to do things. Especially when it comes to oil pan gaskets, it's a lot nicer to install it with the main seal on already. So we just popped it off real quick. While it's still a super lightweight short block and it's not an absolute unit of a complete engine, I'm just gonna throw the rear main seal on real quick. Get our new gasket on, get our new main seal, and get that thing all nice and tight and torqued down properly. So, and there's our crankshaft fully installed with the cradle and the main seal. Our last final check is to spin it over by hand. The thing spins super easy. It shouldn't be hard to spin, it shouldn't bind up at all. So now we can move on to installing our beautiful forged pistons by JE with our connecting rods from Brian Crower. So the first thing we're going to do is open up our oil control rings and get those guys on. Putting a little bit of oil in the ring grooves just to make them go on a little bit nicer and sit a little bit easier. So we're going to put our oil control rings on first. And JE actually provides a orientation chart for the ring end gaps, including the oil control rings. So there's 3 little oil control rings in there. Now we can start putting on our second compression ring. Get that guy dropped in there and get the orientation of the ring correct. And now we can go for our top compression ring. We're gonna get all of our pistons set up, all of the rings on with the orientations correctly, and we're just gonna set them down and we can start popping them into the motor. So I cleaned off the cylinder bores. The block had been sitting for a few days. Get it nice and clean, put some fresh oil on there. Make sure our ring gaps are lined up properly one last time, and then we're gonna put some oil on the piston rings and the piston itself. And then I got my little piston ring installer tool there for dropping the piston in, so that will actually clamp the piston rings down and it'll allow me to pop the piston into the block. Just lowering one, and you always want to make sure that the crankshaft is at bottom dead center when installing pistons. So we're going to install cylinder 1 and cylinder 4, and then check our rod bearings, and we'll go for 2 and 3. So a lot of guys will just do one swoop with a hammer to get the piston in. I find that doesn't really work too well for me. I like to just gently hammer them in, because if you get it wrong on one swoop or this tool isn't seated correctly, you can just outright snap a ring. So not a big fan of snapping rings. So I like to do it nice and slow. So now we're going to clean and oil cylinder number 4. Make sure our ring gaps are where they should be. Get our beautiful tool on there. Make sure that guy is nice and tight. You got to make sure the tool is straight on the piston, because if it's a little bit off, sometimes a ring will slip out between the tool and the block, and if you pound it, then you have broken rings. Nice and gentle, the thing slides right into place. And there we go. You can push it down. Now we can rotate the block over and check our bearings. Setting a little bit of plastic gauge on the journal, and now we can throw our rod cap with our bearing on. Whenever using plastic gauge, you want to make sure that the bolts are torqued to spec, because that is the final bearing clearance. You're measuring clearances in the thousandths of an inch. Now we're just torquing our main caps. Now we're going to crack those guys loose, check our bearing clearances, and if they're good, we're going to lubricate everything and go for final assembly on those two. So rods can be a little finicky when you take them off. The rod caps have a tendency to kind of get stuck, so usually I'll back the studs out, back the bolts out a little bit, and just give them a nice little tap from the hammer, and it'll drop the bottom of the rod down and the cap will come off very nicely. So our bearing clearances were actually right in the middle of spec for those two. So we cleaned them, cleaned the plastic gauge off, put some good assembly lube on there, and now we're moving on to cylinders 2 and 3. So just dropping those two pistons in. And it's going to be the same deal for 2 and 3 as it was for 1 and 4. So we're going to flip it around, install our bearings, plastic gauge them, make sure that they're good. Get those guys torqued, crack them off, and our bearing clearance is, again, right in the middle of spec. So it's nice that this bottom end is going together so well. That's a benefit of having a good running engine to rebuild. With engines that are really old and really worn out, sometimes you'll be mixing multiple bearing sizes to get the clearance that you want. With this engine, standard size bearings just got us all the way on everything, which is awesome. Just finishing up the last one, perfect, clean it off, lube it, and go for final torque. And there it is, our rotating assembly is done. Rings, bearings, everything is in good shape. I always like to spin it all by hand, make sure everything feels good, everything spins nicely. And there's the top shot of our short block going to work. So now we can start installing our oil pump. So new gasket on there, get the filter housing on, get all the oil pump stuff torqued to spec, make sure everything's good, going at it with the torque wrench. Now we can drop our freshly painted beautiful oil pan on. Start running our bolts down, get that thing torqued correctly, which is very nice. And now we can start installing our cylinder head. So I've got our head studs on there, I've got all of the cylinder block threads cleaned. Everything is in good shape, so we're going to tighten these guys down by hand. I usually will drop the gasket on and then the head on and then put the studs in, but since the studs in this are a little bit hard to get in by finger with the head on, we're going to drop the studs in first, put our HKS MLS factory thickness head gasket on, clean the cylinder head for the last time to make sure everything is good, because it's been sitting for a couple of days since we got it back from the machine shop. It's always good to just clean everything you get back just to make sure it's perfect, and we can drop the cylinder head on. Now we can start fishing our washers and our studs on. Got some good ARP fastener assembly lube on there. We'll just go down the line one by one. I'm using a pick to kind of align the washers because I can't get both fingers in where the head studs and where the head washers go. So using a pick to get it a little bit easier, and now we're just going to start torquing these guys down. So there's the first round of torque. Setting up to the second round of torque, and then we'll go for the final round of torque. And there it is, our cylinder head is installed, and now we can start going after our 3G lifters. So I dropped the lifters in a vat of oil. They've been sitting there for I think 2 days. Get those things nice and primed. Sometimes lifters out of the box will have air in them, and so you just set them in a little cup of oil like that to get it all out. So dropped our lifters in. Put some assembly lube on the valves. The top of the valves where the rocker sits, we can put assembly lube on the rockers themselves. And then we can assembly lube our cams. So we got stage 2 Brian Crowder cams. These are a 272, 268 camshaft. Beautiful little cams. So we're gonna start dropping our caps on, get our bolts on, and then we can start working our torque on. And now we can start installing our exhaust cam. Dropping our rockers on. So these rockers are in the same orientation that they were on the original motor. I'm not too sure if that makes that big of a difference now that we've replaced the lifters and the cams, but it's always good, kind of just good form. So dropping lube on the cam journals, lubricating our camshafts, and then we can start dropping our cam caps on. So now we can install the cam position sensor that's on the back of the intake cam. So this has like an entire independent housing for a little trigger wheel that goes on the back. So we can get that unit on, installed, and torqued. Putting a little bit of Loctite on that bolt before we tighten it down. And there it is, torqued, and then the cover can go back on. Now we can put our water pump on, get the gasket on, get that guy torqued, and we're going to start putting some of our timing cover dust covers back on the engine. So these dust covers are just bolted on by a few little 10mm bolts, and then one of the dust covers is mounted behind the main engine mount bracket. So we can torque that main bracket down, and then our dust covers will be on. I've also got one of our idler pulleys on, so there's the timing belt tensioner assembly going on, and then there's the timing belt tensioner rocker arm with our new pulley on. And then we can start tackling our cam gears. So these are our adjustable BC cam gears. We are going to be running this engine for good drivability, performance, and torque, so we're not going to be degreeing the camshafts on this engine. We're just going to run them straight up. These cams are also designed to be run with straight up factory cam gears, so it's not that big of a deal. If they were insanely large camshafts, I would opt to degree them for better performance, but we want good drivability, good power, good torque out of this engine. So we're going to prime the oil system, and that entails completing the oil system. So we're going to put our new turbo and manifold on. I want to get the oil lines and the oil drain hooked up so we can prime the engine. So oil priming is pretty much just getting the oil pump moving, and I wanted to do this before we put the timing belt on, because once the timing belt is on, the oil pump is driven by the timing belt. So once the timing belt is on, we can no longer prime the oil system. So pretty much what we're going to do is fill up the motor with oil, put the oil filter on, and spin the oil pump and get oil going through all of the galleries, all of the passages. Everywhere that oil should be is going to be getting oil through priming the system. So spinning on our new beautiful can oil filter, we're going to be using some 5-way-30 300V Motul racing engine oil, high zinc oil, which is going to be excellent for this. So I've got a little drill with a socket on there, so we're spinning the oil pump by itself. So this is going to spin the oil pump, it's going to pull oil out of the oil pan, and so it's going to pump oil through all of the oil passages, and as you can see, we got oil squirting out of the top of the head. So I want to make sure that oil is coming out of the cam bearings, the cam journals, everywhere that needs to be getting oil is getting oil. So now that the system is primed, we can go ahead and throw on our beautiful blue Agretti timing belt, and there's with the timing belt installed. Thing looks fantastic. So Ricky went ahead and cleaned and painted our valve cover. So now that that thing is nice, beautiful, and dry, we can put our valve cover gasket on and get this thing torqued down. Beautiful green. It's going to complement the chassis of the car very well. And one of the final touches, Mickey is going to hand paint the DOHC and the 16 valve emblems on top of the valve cover. Now we can put our beautiful ignition wire cover on, carbon fiber, throw the entire valve cover and that on with some Downstar, and throw a super clean throttle sticker right on that to match with the valve cover paint. guys, that is it for our 4G63 Turbo long block. The long block is complete. We still have a lot of things to go onto this engine, such as covers, accessories, pulleys, belts. We still have to figure out our intake manifold system, fuel system, coolant lines, all that stuff. But the long block is complete. This thing went together very well. I couldn't have been happier with how the short block came together and everything else just fell into place. So thank you to our partners for making this engine build happen. JE Pistons, Ryan Crowder, Gretty, Motul, and all the other partners that made this build happen. Within the next few weeks, we should be getting the Eclipse chassis back, and then the real party begins, putting this thing in the car, making it run. It's gonna be beautiful. Thank you for tuning in. Comment down below if you guys enjoy seeing content like this. I love building engines. It's one of the most satisfying things about being a car guy. Don't forget to like and subscribe, and I will see you guys in the next one.